Okay, I'm going to go over a couple of the practice problems from the segments and circles practice. So number 2 says LS is tangent to circle Q at point S. If LS is 6 and the diameter RT is 8, how long would QL be? Okay, so in this problem, we're trying to find the length of QL. So QL is this line segment here. That's what we're trying to find. Okay, the measurements that we're given LS is 6, and we know that the diameter RT is 8. All right, so there's a couple theorems that we are going to use here. The first one being the tangent to a circle theorem. Okay, so I'm going to say by the tangent to a circle theorem, QS is perpendicular, and this is a symbol for perpendicular, is perpendicular to LS. So triangle QLS is a right triangle. So this angle is a right triangle. Okay, so we also know that our diameter is 8, which would mean our radius is 5, or which would mean our radius is 4. So since RT equals 8, the radius QS is 4, since the radius is half the diameter. Okay, which means that this length right here, QS, our radius, would be 4. So now to find the length of QL, I have my right triangle, which I'm going to redraw here. This is 4, this is 6, this is QSL. Now using Pythagorean theorem, I can solve for x. So in terms of explanation, this is what I would be looking for. Okay, you have to justify that this is a right triangle, which then means you can use Pythagorean theorem. And you should explain how you know that QS is 4, since that's the radius, and the radius is half of the diameter. So using Pythagorean theorem, we have 4 squared plus 6 squared is equal to x squared. So 4 squared is 16, 6 squared is 36, is equal to x squared. So x squared is equal to 52. And then we're going to take the square root of both sides. So square root of 52 is about 7.21. So QL is 7.21. All right, now I'm going to go over number 6. So number 6 says find the length of AC. So AC is that part right here. So I'm going to use a couple theorems here. The first theorem is the tangent segments theorem. And the tangent segments theorem states that when we have two lines tangent from the same point, those line segments are congruent. So tangent segments theorem states that when two lines, or when two segments are tangent from the same point, they are equal. So that means AB is congruent to AD. So that means we can set AB, which is 5x minus 6, equal to AD, which is 4x plus 2. All right, solving for x, we're going to subtract 4x from both sides. So I have x minus 6 equals 2. And now we're going to add 6. So x equals 8. All right, so now that we have 8, we're going to plug in 8 where we see it. Okay, we're solving for AC, which is the hypotenuse of this right triangle. So something else I should say here. I'm going to say that triangle ABC is a right triangle because AB is perpendicular to BC by the tangent to a circle theorem. Okay, so now I can use Pythagorean theorem. So first I'm going to plug in 8. So now that I've solved for x, I'm going to plug it in where I see it here. Okay, so this is 5 times 8 minus 6. So 5 times 8 is 40. 40 minus 6 is 34. And then I'm going to plug it in here. 2 times 8 is 16. Okay, so using my right triangle, which I'm going to redraw here. This is triangle ABC. And now that I've plugged in x, we know that this is 16 and this is 34. So now I could just use Pythagorean theorem. So 34 squared plus 16 squared is equal to c squared. So 34 squared is 1156. 16 squared is 256 is equal to c squared. So c squared equals 1412. And last step is we are going to take the square root of both sides. You get that c is about 37.58. So AC equals 37.58.